welcome to Data Science Festival and welcome to Data Idol Summer School. Great, it seems like everyone can hear me. Welcome to the session. I am Maggie. I'll just give everyone a short introduction of myself, of Data Science Festival, and our guest speaker today before I get started. So I am Maggie. I am a machine learning scientist at Bumble. I have been in Bumble for just over a year working in the data science team. So we are, in case you don't know Bumble, we are a online dating platform, and as you can see in my background, we encourage women to make the first move. And within the data science team, we work with a lot of different stakeholders within the company, supporting integrity and make sure that all our members on the platform have a great experience. And a little bit about our speaker today, Matt Howell. Matt is a very experienced, welcome Matt.
Hi there, hello.
Yeah, Matt is an international conference speaker, a published author, and a very accomplished data science practitioner. He's got many years in the industry, and he's currently working as a principal consultant for Adatis. Matt delivers enterprise-scale advanced analytics platforms through the implementation of bleeding-edge technology and is constantly working on innovative technologies and patterns within the data science space. I'm sure all of you here know a lot about Data Science Festival already. I'll still just give you a little bit information around that. The Data Idol Summer School was a pilot program, which was first launched in 2021 in partnership with Data Science Festival. It's a really, really nice community to support whoever's interested in this field and wants to progress further and wants to connect with people in the field. Attendees can join our summer school each year to learn all sorts of topics, basics of data science, and kickstart their journey into the career. And we have these sessions live as you are joining us now, or these sessions are also recorded. So you can learn at your own pace later in the year if you want to rewatch all these sessions. And these recordings will be sent out 1st of September to everyone who has registered. So don't worry if you've missed some notes or some information during the live sessions, you can always go back and watch them again. And thank you, Matt, for joining us today, for sharing your experiences in your previous work and give us the talk around how to manage Data Science Festival. I guess last thing before I hand it to you, Matt, I'd like to remind everyone that we have Q&A function in the bottom of the screen. You should be able to see the Q&A button where you can click and put all your questions there. And at the end of the session, we'll be able to go through all the questions and Matt will be here to answer your questions. Okay, I think that's all from me, and I will hand it over to you, Matt, if you want to share your screen.
Lovely, thank you very much, Maggie. Thank you for that lovely introduction. I'll just share my screen now. Excellent. I hope everyone can see my screen there. Should be able to see the title slide saying about running a data science project and how you plan for success with data science. And of course, that's the topic of my talk today, is how really you manage and get through a data science project and make sure that you get a successful outcome at the end. So let's get into it. So Maggie's given me a great introduction there and covered a few of the points that I've got here. So this saves me a slide, which is nice. I think the key thing that I want to point out on this is that I'm a principal consultant working for a company called Adatis, who focus on sort of advanced analytics and data delivery in a whole range of industries. And I've delivered, many different kind of value projects for different clients, and I've got a lot of experience in how those projects can go well and go wrong. And more recently focused on more of the data science nuances. And so I've really seen how data science has to have a particular type of project management and how things can go rather wrong if they're not kind of handled correctly, and if the right compensations aren't made for data science. So that's what I'm going to focus on in this session today, and really talk through some of the experiences that I've had managing data science projects. Okay, so in terms of a loose agenda, there's kind of four main things I want to talk through. The first one is going to be sort of setting a baseline around typical project management. So when you go out into the world today and you start working on kind of software and data delivery projects, there's kind of two styles that we'll talk through and how they kind of work. And there's pros and cons on both sides. But I think as we come through that section, we'll realize that there's a kind of a strong winner of a project management style that we can use. Then we'll kind of talk about how we take that project management style and adapt it for data science specifically. So when we're approaching a data science project, what do we need to consider? Then talk through a process that kind of leads us from end to end of a successful data science delivery. And I'll talk through each step of that process and the kind of things that you should be thinking about or looking at or kind of doing and performing whilst you're going through that process, so that you can actually see how that end to end works. And then lastly, kind of like a project manager's toolkit, you know, these essential project artifacts that are just going to make your life easier when you're trying to either deliver or manage or work amongst a project team that are delivering a data science solution or use case or whatever it might be. So these are kind of the key things that you want to have in your pocket. Okay, so let's start with sort of this understanding of what typical project management looks like and the kind of things that we generally see kind of out in the wild when we're building out data or data science solutions. Generally speaking, there's two approaches to kind of software and development project delivery, and these are waterfall and agile. And I'll explain what both of these approaches are and the various pros and cons of each. So we'll start with waterfall. With waterfall, the first thing we do is we start with a plan. We want to create a nice big plan that's going to have everything that we want to achieve in that plan. And so what we do is we in that plan, we kind of identify all the different requirements that we might want to gather. So these are all the people we might want to speak to, and all the things that we need to then sort of plan to deliver as we go through the project. So we want to list out a nice big list of everything that we want to attack whilst we're working through this project. And this is quite good, right? Because people like lists. There's good visibility around a list. People can see everything that you're thinking of and considering, and everyone can kind of get behind the list because they can kind of agree all the things that are on it. So once we've got our big list of things that we're going to do, we then start thinking about project delivery and how we're then going to deliver all those things that we say we thought about. So then, of course, now we've got our list, we can start to put some timescales behind it. We can start to think, okay, who's going to do what? So, you know, the web design team are going to do something over here. At the same time, we might have the database team doing something around the APIs, for example. We can start to create this nice big kind of sequential list of things and a kind of a path through the project. And you can start to see why this kind of style of management gets called waterfall now, because you've got a nice sort of flowing project plan there that sort of leads out with a nice long tail at the end for delivery. So you can see we've got all the kind of the requirements and all the people that need to do various things at various different times before we actually get into the kind of ultimately into the project delivery. And of course, on top of this, we can start to layer things like milestones. So we may have milestone 1, which might be get through a certain governance or approval gate for our planning at that point. Milestone 2 might be like, right, we've finished all of our planning, let's go into delivery mode. And then milestone 3 might be, right, let's wrap up the delivery and make sure everyone's kind of got what they need, and let's go into you know, training or learning and development and testing, that kind of thing. So you can see a kind of fairly typical looking waterfall kind of project plan here. But in this, there's kind of some inherent issues which start to come to light. And the first one here is that, well, when we made our list, did we actually remember to put everything on the list? There's always that concept of unknown unknowns. And did we actually remember to plan everything? So did we capture all of the requirements that we need, or is there something that we've not seen there? Did we actually speak to all the right people, or did we miss someone off our list of our workshops? And you know, let's just hope that something doesn't crop up throughout the project, because we haven't got any means of going back and replanning. So let's just hope everything stays the same. Secondly is, did we actually leave enough time? So when we did all of our planning and we looked at all of the requirements, we said it's going to take X amount of time to deliver on this, but was that actually enough? Were our estimates accurate enough? Did we know all the things we needed to know at the time of planning? And you know, what happens if someone then leaves the team and affects the resource plan that we've got, and we can't immediately fill that gap in the team again? How do we sort of compensate with that? Or is the whole plan then, you know, shot to bits? So, you know, thinking about how much time we're actually leaving ourselves is really difficult with something like waterfall. And lastly, did we actually deliver what we wanted? So, you know, assuming that none of the requirements changed that we set out right at the very start of the project, then hopefully we delivered all of those. But if at any point those requirements change, how do we compensate for that? How do we change what we're doing to kind of to address that? And what happens if we're then left over with a load of technical debt? So things that we had to deliver in one way, but actually probably should have been delivered in a slightly different way. And, you know, obviously, let's just hope there was enough money in the budget to actually get us to that point. So there's a number of sort of rigid elements to waterfall that make it quite a tricky management style in sort of for modern day projects. So just to kind of summarize that then. So the pros of of waterfall, sorry. So allows a lot of time for planning and design, you know, plenty of thinking time and design time to make sure we've kind of got as much of that stuff that we can think of at the time all kind of fleshed out. It's quite a simple to use framework. It's very easy to understand how things happen sequentially. And then as you move out of one phase, you sort of move fairly robustly into the next one. So it's quite simple to use. And, you know, certainly in a lot of organizations that I work with, it's very common that people are very well adapted to using a waterfall style, and it can be difficult to kind of change that. But the nice thing is, you know, a lot of organizations are already set up to deliver waterfall style projects. So the cons then are things like it takes a long time to deliver value. So looking at that project plan, if we say we're going to start at the start of the project with some planning, it's an awfully long time before we actually get all the way to delivering some value back to the business or the consumer or the customer or whatever it might be. You know, there's no real sort of ability to kind of deliver value quickly. It's also very rigid. It's not particularly flexible to change in technology or change in direction or change in requirements. You know, if someone suddenly says, actually, our priorities have shifted and we need to do something else, there's no means to then go and do some more requirement gathering. You know, you've already planned everything out. It's already in a big, long plan that has to be sort of facilitated. So it's quite rigid. And obviously by that logic, then minor bumps in the road can really derail the entire project, can really affect that critical path to ultimate delivery. So that's kind of a little bit of an overview of waterfall. The other one I mentioned then is agile, which has sort of some of the benefits that waterfall doesn't necessarily cover off. So for example, we start with an initial planning and discovery phase. And the goal of this is to really understand what the requirements are again, so similar to waterfall. But really, we're just trying to get to a point where we can get started. We're not looking to understand every single minute detail of the things we're going to deliver. We're just looking to get an overall feel, and we'll kind of work out various details as we go along the way. We then make a big list of all the things we want to deliver. So rather than just sort of thinking about delivery as one massive chunk of work that everyone's going to work on together, we can start to single out different bits of sort of business value or customer value. So for example, things like here, like the new customer experience is a single piece of value or delivery that someone can attach a real meaning and value to. So we start to single those out, and we put those into what's called a backlog. So underneath each of these sort of value points, there'll be a backlog of work, which is all the kind of individual items we need to deliver in order to deliver that ultimate piece of value. And then as we start to go through, we can then start to think about how we actually deliver that. So for example, once we've got our backlog, we can start some development, we can then do some testing, and we can then deploy that out. Okay, so that route to value is much, much shorter because we're focusing on a thin slice of the delivery. We're not trying to flush out everything in one go. We're saying just take this thin slice, this one piece, customer experience, and deliver that, get that across the line. And then you can kind of scale that up. We can run in parallel if we've got enough sort of developers and resources in the team. And you can start to see how this project plan starts to fill up, but offers a lot more parallelism, a lot more flexibility. And as I say, it delivers value back to the business or the customers or the consumers much, much quicker than in a sort of traditional sort of waterfall style. The way that we then break this delivery up then is actually in what's called sprints. So generally speaking, we'll start with the sprint 0, which allows us a bit of time for planning and backlogging and getting ourselves set up. And we then can iterate through each and every sprint. So I've got here sprint 1 to 6. As we go, we're kind of working through various different steps of work in each and individual sprint. Now, sprint may be a bit of a new term if you're not too familiar with the concept of agile. So kind of here's a little look at the anatomy of a sprint, if you like. So here I've got a 2-week period, and that's typically what we see as the size of a sprint is about 2 weeks. So I've got my 10 days here, my 5 working days of each week. So the first day, generally speaking, is focused on planning. So we're going to plan out our work for the next 10 days. We're not trying to plan the entire project. We're just trying to plan the next 10 days, know exactly what we want to do for those 10 days. Throughout that sprint, then we also do what's known as backlog refinement, which is then looking at the backlog of work that's coming up in the future and understanding if we need any more details around any of those particular work items, whether we need to unblock any dependencies, whether we need any additional data, for example, and essentially just ensure that we're ready for the next sprint coming so that we can just do a bit of planning and go straight on into that next sprint with everything we need. So that's really a little look into the future to make sure we've got the things we need. And then we usually close down a sprint with a kind of a public sprint playback, which is where we play back the progress of the previous 10 days. We may do a little sort of demo about, what we've actually delivered, and these are the kind of things we're working on for the next sprint. But generally speaking, it's a really good opportunity to cover off what you've delivered, but then also get feedback from the business or from the customers, or whoever is kind of the value owner, to make sure that what you delivered is continually delivering the right value and hitting the requirements. And that feedback is really what Agile gets its name from, is being able to respond to that feedback at a very, very regular interval. Throughout the sprint then, you generally have daily Scrum meetings, which is typically 15 minutes every morning, whereby people will cover off what they did yesterday, what they're planning to do today, and then raise any blockers that might be stopping them from completing their work. And having that really kind of daily catch up means that if there are blockers or things that need to get sorted out, there's always that opportunity to do so. So let's just do a quick summary of Agile then. So, of course, the pros here are the flexibility and the the inherent agility that we get from an Agile delivery style. It shortcuts that time to value by taking out thin slices of delivery rather than going for everything all in one go. And it promotes the self-organization of your team. It encourages people to be thinking through and self-starters. So the things that slightly maybe against Agile, so in some cases, you see people that are trying to adopt Agile, but are maybe a little bit inexperienced, can really struggle to get the right way of working, and can take a little time to sort of settle into that process, just to get the right cadence, get the right meetings in place, get the right agenda for those meetings. That can take a little while to settle into. And it does require a little bit more discipline. So, you have a Scrum Master who is there to kind of oversee and manage that Scrum process and the Agile process. And that can take a little bit more discipline than a typical project management with waterfall, for example. Now, there are often, as kind of anything in the modern day, there's sort of alternatives and things have got blended and mixed together. So you do occasionally see things like agile, which is essentially, you do a lot of planning up front, but then deliver things in an iterative and agile manner. I've also heard it called agile waterfall, and probably the strangest thing I've ever heard it called is waterfagile. So look out for those terms, but they essentially mean it's a combination of waterfall and agile, trying to pick and choose the best bits of each and give that some sort of strange name like waterfagile. So generally speaking, which one do you think we should use? So on nearly all, like 80% of the time, I think agile is the best way to go, particularly for these sort of modern, innovative projects that data science typically falls into. Very occasionally, waterfall can work, but that's usually mandated by, say the customer that you might be working with or the client that you might be working with. And then also, slightly more often, a sort of a hybrid approach can also work. If there needs to be a lot of planning up front and a lot of sort of approvals and that kind of stuff, then a slightly agile approach can also work. But largely speaking, agile is the way to go. Okay, so knowing that agile is generally sort of the thing that we should be thinking about when we're sort of planning out our project approach. Now let's think about, what were the specifics that we need to think about for data science? Because there's a kind of a fairly sort of well-known and probably quite well understood sort of checklist of things that you would need to run a successful project. And I've got a few of them here. It's not exhaustive, but obviously clear user requirements, knowing what we're trying to deliver and that everyone is kind of signed up to those list of requirements is really important. Having the right people to explain what this piece of data means and explain how this system works is really, really important. So those subject matter experts are crucial. Having the right level of planning so that you can actually, what everyone is doing, making sure that you've got the right budgets and forecasts and all that kind of stuff is really, really important. Obviously, without business buy-in, you're not going to get off the ground anyway. So making sure that you've got stakeholders and the right level of senior leadership behind you in the project. Obviously, technical capability. So can we actually, technically do this thing? Have we got the right bodies in the team to do it? And have we got data available? So all of those things are pretty germane to almost any project that you might want to try and deliver in the sort of data space. But as I say, we've got some things we need to think about for running a successful data science project, which don't necessarily cross over into that more atypical list. So these are things like feasibility analysis. So if it's just a traditional analytics project, generally speaking, if you've got the data, you can do some analytics with it. But if we're trying to do sort of predictive analytics, is that actually feasible? Does the data lend itself to being predictive, or is it simply not possible with this particular type of data set? What are the ethical considerations? So this is something that is really, really kind of popular at the moment, is this whole concept of ethical AI, and making sure that whatever we're building as part of an AI solution is not, inherently bringing in some sort of bias, or, or is not acting ethically. So what ethical considerations do we need to think about when planning our projects? Another one is computational power. So this does somewhat bleed into the other list, but generally speaking, there are nuances to the way data science projects have to operate. That means that computational power, it needs to be thought about a lot more in advance. There may be specific cases of needing GPUs or certain types of compute, that mean that you have to have a think about that ahead of time. You can't just get an off-the-rack PC to deliver this certain type of project. And what about the inference scenario? So you may find that actually, when you've trained your model, then you want to deploy it. Is it going to be a real-time inference scenario where things need to be returned sub-second, or is it going to be in batch where things can run overnight? Knowing where you're trying to actually run these models is really, really important, and will massively affect how you deliver and how you work with that project. So that's kind of our checklist to be thinking about. So that's going to have a look at, for each of those sort of additional items, what we need to be thinking about as we're sort of trying to check off that particular item. So first thing here is feasibility analysis. So how do we sort of go about making sure a project is feasible? So the first thing is kind of a question. So is the relevant data that we need for this project, is it actually available? Can I see it and touch it? Can I go and get it from a database or from a SFTP somewhere, or from an open source, wherever that might be, on the internet? And is it in an accessible format that I can work with? Or is it in some, strange proprietary format where I have to pay a fortune for a specific tool to be able to download and use it? So, how actually tangible is the data is the first thing. If we go, actually, no, it's not tangible at all, we need to rethink that. Maybe you can go back to a source system expert. Maybe they can do something to help you, make that data more accessible. But if we assume that's a yes, we can get it, we can touch the data, then we need to think about, well, do we have enough to actually support the use case? Commonly speaking, data science projects need a fair chunk of data, particularly once it's been cut up into different data sets. So have we actually got enough data to be able to kind of make this a solution? So if the answer is no, then we may need to go back to the subject matter experts. Can they gather more data for us, or can they produce more data? Is there another area that this kind of similar data sits that maybe we can pull on to help us beef up our data set? But if that's not the case, then we can start to ask ourselves, well, can we actually, can this data be used to effectively predict the chosen target? And if the answer is no, then maybe we need to go back to the subject matter experts again. Is there a way that we can change this data so that it can do that? But if the answer is yes, then generally speaking, we know that the project is going to be feasible because we can get the data, we can get enough of the data, and that data itself can be used to predict the target that we're looking at. So using that sort of three-step process, we can kind of get a fairly good assurance that the project's going to be feasible. So how about the ethical considerations? So generally speaking, when tackling this, it's good to sort of put everything out on the table. And generally speaking, this starts with a project committee, okay? We want to get everyone sort of round and kind of flush out any of these considerations or concerns and get them all out in the open at the start of the project. Otherwise, you can find they start to derail things as we go through. So it's really important to have a nice open session at the start of a project. So, things to consider is things like, are we going to use personally identifiable PII information for this project? And if the answer to that question is yes, then immediately there's an ethical consideration to think about, have we got the right data protection obligations? What do we need to do to keep these people's information safe? Have we done the right data assessments? So like DPIAs, for example, to make sure we're allowed to use this data. Have we told the users or the generators of this data that we're using it in this particular way? There's a number of considerations around using any PII data. Of course, a classic one that we see a lot now in the ethical AI space is this model going to be making decisions that could affect an individual in any way? And if there is that, then we need to be really, so for example, like loan approval, we need to be really careful that that model is not going to make any biased decisions, and that it is making decisions in a fair and trustworthy way. Yeah, and is there any bias that needs to be addressed before training this model? So, occasionally you see that inherently within a data set there is bias because we maybe don't have enough contrasting data, so therefore the model learns a bias that way. Or occasionally where data has been human labeled, then a human's bias has been brought into effect there, and then again the model will learn that because it's got no other way of sort of formulating its opinion on that data. So understanding those different ethical considerations is really important at the start of the project. And there's generally a few tools that you can use. There's a few that I'm aware of. So Google have a tool called What If, which allows you to do that sort of analysis around the ethical kind of considerations of your data and your models, and look at how they're being affected. IBM, I think, have a tool called AI Fairness 360, which does very similar things. And FairLearn is an excellent library that allows you to really understand if your model has inherent bias, and how you can then sort of address that. And it also offers some algorithms to help with sort of data privacy and protection, that kind of thing, to make sure that you're not accidentally exposing any particular records or bits of information. So the next one is computational power. So here it's really about just asking yourself a few questions about what we're going to deliver through the project, and then how that relates to the compute that we might want to use, and then what do we end up choosing in terms of architecture and infrastructure. So commonly things like what models we'll be using is a really good one to start with, because some models require more storage than others, some need more data than others. So really what models you're going to be using can really drive the computational power that you need. Of course, deep learning networks need much more kind of training time and training input than say a shallow learning model, for example. How much training data are we going to need? So if we need terabytes of data, we obviously need some sort of compute that's going to be able to handle the storage behind that and handle the processing of it, versus something that needs only a few thousand records. So knowing how much training data you're going to need is really, really important to then sizing up and estimating how much compute power you'll then need. Obviously, if you're working with image data, you may need to bring in GPUs, which is kind of it's a specialist kind of compute. They're not just generally available. So you may need to think about how you're going to get those kind of resources available to you. And additionally, how you're going to fund them. And of course, can you make use of distributed compute power? So very commonly now in the big data space, we see tools like Spark being used that can distribute data across a whole network, a whole cluster. And can we make use of that distribution to actually make our our data processing, our training, etc., more efficient? Or are we limited to kind of a symmetric processing on only sort of a single laptop or a single PC, for example? And what you'll find is that all the big cloud providers like GCP, AWS, Azure, they've all got ways and solutions to kind of all of these questions and problems that you can kind of pick up quite easily, the solutions for these. There's an excellent tool called Databricks, who I know also presented at the Data Science Festival, and they offer this excellent kind of Spark-based platform that is really good for sort of covering off a lot of these use cases and these questions. So I think the last thing then is kind of looking at the inference scenario. So typically speaking, if we have a user that is looking to kind of use a data science platform in some way, there's kind of two typical ways that they might be looking at doing inference. So either they're going to send a message in real time and expect essentially a prediction or an answer back from that AI almost immediately. So here we have sort of an online sort of flow. So we might have an API that sits on the internet, for example, that generates a prediction and then responds with a message back to that user. That's one way that we can do inference, is online and sort of in real time. And of course, the other option is the nightly batch, sort of a typical, ETL, extract, transform, and load style. We load a table, we generate a prediction for each row, we store those results, and then we either serve up those results as we need the next day, or we pass them on to some sort of database that the user is then using. So we need to really ask ourselves, which kind of inference scenario are we going for first? And that's going to massively change how you structure the project, what you deem as success versus what is kind of not successful, and all that kind of stuff. So it's really important to understand what we're aiming for in terms of an inference scenario at the start of the project. Okay, so that's the kind of the data science specifics, the checklist, if you like. I say it's not an exhaustive list, but it's a good few things to start thinking about from a data science perspective. Okay, so now we can talk through a bit of a process. So the idea of this process is something that will guide you through the steps that you need to do when delivering a data science project. And so long as you follow broadly along this process, then hopefully you should sort of tick off a lot of the kind of the check boxes that you need to make sure that you've got everything kind of running successfully. But also it should mean that there's enough governance and there's enough kind of structure in there to make sure that the outcome of the project is a successful one. So hopefully this process gives everyone at least a starting point when they're planning their projects as to the kind of things they're going to need to tackle and do throughout the project. So this is what the process looks like. So we start with solution envisaging. So this is all about our planning and our prep and understanding the use case that we're going to tackle. We then move into data collection, and that's all about making sure that we've got the data and that it's accessible to us and we've got enough of it. We then move into exploratory data analysis, or EDA, and feature engineering, where we start to understand the shape and size and kind of structure of our data. We get to really know our data inside and out. And that's going to tell us, is that data feasible for doing predictive or machine learning, for example, and what kind of issues might there be in the data that we might need to address. Then we move on to model evaluation. So this is kind of, the fun bit. Let's get trying out some models. Let's do some trial and error. Let's start seeing how accurate we can get our results to be. Then we move on into deployment. So actually putting those models out into the wild, maybe into a test environment or out into production. So they're actually being used by end users. And then we move into sort of monitoring. So looking at those models retrospectively, are they still performing? Are we suffering from model decay? Are we still getting the value that we expected to get from that model time and time again? And lastly, is sort of a review phase where we can just kind of do what's known as a sort of a drains up approach. We can look at every aspect of our project and say, have we done all of this correctly, or is there something that we might change? And as you can see, these whole sections kind of fall into different parts of a project. So you've got a kind of planning and prep section. Then you move into some agile iteration. So this is something that can be iterated over and over again as we refine and get better at what we're doing. We then have that delivery assurance piece to make sure that what we've delivered is actually useful and is continuing to be useful. And then obviously evaluation to make sure that what we did was actually good and decent and we can stand by it. So let's walk through the process in a little bit more detail. So starting with the solution envisaging. So the first thing we're going to do is list out the issues, get the business in, get the customers in, whatever it might be. And let's start listing out some of the issues and try and identify some of the key issues and challenges that people are facing that might be addressed by a machine learning or a data science or an AI type solution. Then we look at the big picture. So so from that detailed list of issues, let's sort of put them into a broader context. Where do they actually sit within that business or within that customer's journey through our website or through our business, that kind of thing. Looking at the big picture. Talk a little bit about the evidence. So, could the evidence be something like taking a very, very long time to get to the particular web page they're looking for? That's kind of evidence that there's something going wrong and that maybe we could actually, do some sort of machine learning to help identify the correct page to serve them much quicker. So, that kind of evidence is really crucial because it gives credence to the various use cases that we're looking at. The next thing is to look at is the resources. So what do we need to actually then deliver this solution? What data do we need? Which people do we need to talk to in the business? All the different resources that we might need to string together in order to actually deliver something. Can we flush all those things out in one go at this point? And lastly, we then start to define candidate solutions. So we start to talk about and sort of solutionize and essentially envisage what a solution might look like. And people can go, yes, that sounds great. That would really work for me. Or they can say, no, actually, that's not quite right. We need to sort of rethink that back to the drawing board. So it's a really good way to sort of just prototype a little bit and get things out on the table. In terms of the audience for solution envisaging, we generally need to see that we have a good sort of cross-section of the market we're looking to address here. So you might have decision makers and leadership who can kind of bring the project sponsorship and the sort of high-level steer. We might have source system and data experts who know exactly the individual data points, the individual columns that we're going to need to use and how the nuances of that data behave. Obviously, we're going to have data scientists and analysts who can bring the technical expertise about how something might be achieved or what challenges might lay ahead. And then you've got subject matter experts who are generally, they could be the people that are going to benefit the most from the solution and know that issue inside and out, can really help to kind of broaden out the big picture and the evidence that manifests itself with those. Once we've kind of got those things fleshed out, we can actually start to do a bit of a prioritization exercise. And this is kind of what we call a Boston grid. So we essentially measure the impact of delivering that use case and trade that off against the simplicity or the complexity of implementing that. And we can start to plot on a few different use cases. So I've got some kind of common examples here. And you can see from this that obviously customer churn is going to have a really big impact. So, being able to hold on to those customers is going to have a big impact on our finance, for example. And it's also quite high up on the simplicity side of things. So it's not too difficult for us to try and achieve, essentially. Whereas something like customer segmentation, it's going to have less impact, and it's actually a lot more complicated to implement. So that's kind of really something that we're probably going to put on the back burner. So you can quite quickly identify, using this Boston grid approach, the things that are going to be your target use cases, and that you would focus on first when you're looking at taking on a data science project. Okay, the next thing is then data collection. So obviously we need data to do any kind of data science. And you'll probably recognize most of the sort of formats that I've got on the left here. Typically we see data coming from databases, flat files, of course, APIs, and maybe open data, things like weather data, that kind of stuff that's open on the internet. Typically that would come into some sort of data lake or data storage, and then we can do, whatever data science we're looking at doing on top of that. So, but there needs to be some, if we start just building these things out without too much thought ahead, we're going to find quickly that, we're having to rewrite a number of different pipelines or data ingestion routines, or maybe we're coming across, just scaling up is really difficult if suddenly we have to get 1,000 tables from a database. So we want to think ahead and think about all these different types of data source and how we plan for the different nuances that might be inherent, in those data sources. For example, for databases, are we going to do batch loading? So we're going to get the whole table every single time? Or are we going to do something a bit more intelligent, like incremental loading, where we can just say, just give me the rows that are new or have changed. So I've got a much more sort of nimble batch load, as opposed to kind of getting everything every night. With flat files, have we understood the format correctly? Is it comma delimited or pipe delimited? If it is a flat file that's kind of text-based, like a CSV, for example, are we going to be able to regenerate the correct data types to make sure that all the numbers truly are integers and all the dates are actual dates and that kind of stuff? With APIs, there's always issues around pagination. So if we're getting a lot of records, we may need to iterate through a number of different pages rather than trying to get them all in one go. Obviously, there's authentication essentially across all of these sources. And with open data, is that data trustworthy? If we're not owning the source of that data, can we actually trust where it comes from, and that the people that we're getting it from are delivering this data in a trustworthy manner? And how often is it refreshed, and who maintains it? All these questions that might sit with something that's not necessarily under our control. So thinking about these things ahead of time is going to really save you a lot of time when you start to sort of scale up and work through the project. So EDA and feature engineering. So we get into sort of the fun, data sciencey bits now. So the thing we need to ask ourselves, and this is similar to sort of that feasibility analysis, is can this data support predictive analytics? That's kind of an underlying question that we have when we go into EDA and feature engineering. We might start looking at, are there any data quality issues that need addressing? So are there, for example, anomalies that simply don't make sense with the rest of the data? Or do we have some really key columns that simply have some null values that we might need to sort out? Data quality issues, where are they and what do they need to do to be fixed? As I said, anomalies. And ultimately you sort of find yourself asking, well, what features do I need to create? What am I going to extract from this data set that is going to give me the most optimal machine learning algorithm? And that's as you sort of start moving into feature engineering, that's kind of very much a trial and error, a very iterative process about what features are we going to actually select for our data science models. And the kind of typically the things that we might see through this process is things like histograms. We want to understand the distribution of the data, where we might have a non-normal distribution. Can we do something to kind of rectify that so the distribution is more easy for us to work with? Profiling statistics, so understanding the sort of like how many values are missing from this column, what's the mean and the standard deviations, what's the min, what's the max, all that kind of stuff is really good, just profiling information about your data so the general shape and size of it. And of course the key one for us is kind of correlation matrices, right? Understanding how these different columns correlate to each other is really, really critical for understanding how we might use this data in a predictive manner. So those are kind of typically the kind of things you'd do and you'd see when you're doing your exploratory data analysis. We then move into feature engineering. And this is when we're going to start actually doing stuff to the data. We're not just looking at it now and analyzing it. We're going to start sort of rectifying it and doing things to it. So there might be some very basic transformations that you might do straight off the bat. And these might be things like just dropping columns that are simply not useful. that are too sparsely populated and we don't want to impute the data. We might start training and sort of splitting our data out, so we've got some stuff held back for testing. Another thing to consider is actually grouping features together so that we've kind of got an easier way of managing those features. Then to some sort of slightly more complex ones is data imputation, for example. So if we know we want to use the age column as a key kind of predictor in our solution, but we've got a couple of nulls in there, or a couple of empty values, we might then want to do something like calculate the average age of the entire data set, and then we'll use that as our default to fill in the empty values there. Slightly more sophisticated, you could then sort of use a regression model to try and calculate an age and use that. But essentially, you're filling in blanks so that you've got that column available to use in your machine learning models. Categorical one-hot encoding is really important. So there are some models that can handle kind of categorical data without any need to sort of address it. But there's also a vast number of them that can't. And so we do this process of one-hot encoding where we almost pivot the data into several columns and use a binary flag to indicate whether that column relates to the particular example that we're looking at or not. And lastly, if we're working with imbalanced data, which is, again, very common in sort of the data science space, we may want to do some synthetic minority oversampling technique, or SMOTE, as it's generally known, whereby we sort of readdress that balance either by oversampling the minority or maybe slightly undersampling the majority class, for example. But essentially, we're trying to balance out those two classes so that our machine learning model isn't going to just inherently learn an imbalanced data set. Another thing that we can do throughout model evaluation is set a baseline. And these are really useful for us to know if we're heading in the right direction or not. And a good way to do this is with autoML. There's a number of different libraries and tool sets that provide autoML. And the general principle is, let's take a whole bunch of different types of machine learning model. So for example, neural networks, tree models, linear models, throw them all into a big bag, chuck the data at it, and let's see how all of them get on. And all of them will then spit out a various score. So you nominate your metric, and then you'll find actually that it'll spit out, this is the best model, so you should start here. So as we go into our project, we would then start with a linear model that has a standard scalar at the start of it, and that should generally give us some good results to begin with. And of course, we can then start evaluating those models with the different outputs. We can look at the ROC curve, the confusion matrix. We've got things like accuracy, precision, and recall, all there to kind of get up to help us really understand, is this model good? Is this model naff? Do we need to start again? All that kind of good stuff. Further then to evaluation is obviously we can do some analysis and tuning on that model. So we might have a good candidate model stood up. Now we want to try and hyperparameter tune it to make sure it's performing at its absolute best. There's a number of kind of techniques we can do here. One of them is grid search, where we define a parameter grid. So in this case, I'm sort of defining a penalty and a C parameter. I can put those into a grid, and that then gives me sort of a 4 iteration cycle that's going to go through and try out all those different combinations of parameters on the models. And that's going to tell me which is the best combination based on a certain metric. So in this case, perhaps it's going to say, right, you should use the L2 penalty and a C of 1, for example. And that then tells me that's the best kind of hyperparameter tuning for that model. If you're working with decision trees or random forests, you can start to visualize the trees and start to understand how it's making various different decisions and all the different kind of nuances within that tree, which can be really useful when you're trying to optimize that model. Of course, we can do ensemble modeling. So we can actually take several sort of weak classifiers and stick them together in one big ensemble. And generally speaking, that will outperform single models that are more well-tuned. And of course, we can do k-fold cross-validation, whereby we take our entire data set, we split it up into a number of folds, we train the model and test it, we then shuffle the data again, get a different training set and a different test set, train and test again, and we can start to get an understanding of how well that model is going to generalize on slightly different sets of data. Next up is deployment. So how do we actually get models out into various environments? And this is a kind of an oversimplification, but essentially we take our models, package them up, send them out the door through some sort of mechanism, and that then should then help it to arrive in either UAT, so testing, or production, for example. And things we need to consider here is, some models may require more data storage than others. They might have different packaging formats than others. So the format that we're serializing models in is really important, and the storage that they need is also a good thing to consider. But then also, what method are we going to use to push these models out? And that really depends on the inference scenario. Commonly we see things like Kubernetes being used to help deploy models, and some of those automated tools help get models out the door. And then lastly, what environment are we actually deploying to? And are there nuances about the production data or the production scenario and environment we might need to consider? So thinking about where these models are actually going to land is really, really important. Next up is monitoring. And the key things we want to look out for is kind of three here. There are others, but these are the key three. First one being concept drift. So is our data sort of shifting under our feet? For example, in this age column, we start with fairly low ages, but as we go through, more and more older people are maybe adopting the platform, for example. And so that age column is going to shift. And does that have a knock-on effect to our model? Is that conceptually, is our data drifting? We might need to address something for that. So monitoring for that is really important. Data drift, so we may, perhaps we gain a column, okay, and can we do something useful with that column? Or in some cases, you may see a column that was previously a string column is now an integer column. How do we handle that kind of schema or data drift? It's really important. And last thing is sort of probability, right? So when we trained our model, there was an average probability of, say, 95%. But as time goes on and the data changes, we're now seeing that average probability drop considerably. So knowing that that's happening means that we know then when we might need to think about retraining the model and redeploying a fresh model out to our users. And then lastly is the review process, right? So let's have a look at everything that we've done to deliver that particular model or those models into whatever environment. And let's kind of ask ourselves, is it good? Is it bad? And there's two really good approaches I find for doing this. One of them is what I call start, stop, keep. So things we should start doing, things that we should stop doing, and things that we should keep doing. And that has a good way of kind of analyzing all the different aspects of what's going on. And you can also do, a fairly more typical SWOT analysis. So look at the strengths, opportunities, weaknesses, and threats, and put things into those different categories as the things that you think are going well or not going quite so well. Okay, so that's kind of how we go through that process and the things we need to think about whilst we're going through the process. The last thing now is to go through some of the essential project artifacts. As I say, this is kind of the things that everyone that's kind of working on or delivering or leading a data science project, these are the kind of things that you should be managing and maintaining to ensure that you've got all the information in front of you to make sure you're heading towards success. So the first thing is a resource forecast, okay? We need to know of our team of developers, project managers, business analysts, source system experts, for example, how many days are they doing, when are they working, when are they on holiday? We just simply need to know when people are available and how much we're going to need people. And the key thing here is that we can then plan ahead. So if we know we're going into testing after sprint 1, we know we need to line up some sort of test resource or someone from the business or a customer, for example, to come and do some testing for us. So by having that resource forecast, we can plan ahead. We know how much of someone's time we're going to need and how much they can offer us. The key point here is, remember, no one ever really works 8 hours a day, 5 days a week. Okay, people always need some time for those, those annoying meetings that come into the calendar, or just, getting back to emails, or catching up with their team or their, their mentor or their boss or whatever it might be. So no one really works, 8 hours a day, 5 days a week. So never take that assumption into your resource planning. Bear in mind that people, you need time as a project team to plan and to reflect. So you can't constantly expect people to then be developing all the time. You need to leave overhead time to do planning and have agile ceremonies like planning and playbacks. And make sure that everyone knows about the forecast, right? Everyone should see what they're forecasted to do so they know when they're required and what their commitment is to the project for the upcoming weeks. A RAID log is really important. So RAID stands for risks, assumptions, issues, and dependencies. And this is really going to help you kind of keep track of all the different aspects within the project. I won't go through all the information on this slide, but risks typically might be like, what is going to sort of derail this project, and what is the impact of that, and how do we mitigate that? So knowing what those things might be and knowing the mitigation is really, really important. Assumptions can be things that you assume about the data, obviously, or about the project. And it's really important to validate those assumptions, because what you're saying is, if these assumptions don't hold true, then maybe we haven't left enough time to kind of tackle that problem, or maybe we're not going to be able to deliver that particular use case. Issues are kind of generally things that people we're already aware of, but we just need to manage throughout the project. And it's all about managing expectations. And then dependencies are, of course, things where we have a dependency on the data that we're going to use for this project. We might have a dependency on that team to deliver the data, or whatever it might be. So tracking those is really important. Next up is a product backlog. And I've mentioned this a few times throughout this presentation, but this is all about breaking down work items into smaller and smaller chunks so that we've got kind of discrete tasks that a single developer can work on and deliver deliver throughout the sprints. So generally speaking, we start with epics, which are the headline business term. We then have features, which are sort of broken down, but still in business terms, so people in the business can still understand those. Backlog stories, which are kind of discrete pieces of work, which are owned by a developer and will be sort of given throughout a sprint. And then finally tasks, which are the actual sort of specific technical, you're going to do this, then this, then this, that need to be completed by a developer in a sprint. So a typical backlog might be like this. Our epic is customer churn propensity. So understand how likely a customer is to churn. We might break that out into a couple of features, one of which is going to be the data collection and ingestion aspect of that. Another feature might be the EDA behind that use case. A third feature might be the model evaluation behind that use case. So you can see how you break those down into features. Within that feature, though, there's still individual discrete items. For example, like creating a data ingestion pipeline. That's the first thing that needs to happen. The next thing might be then creating a data cleaning script. And then you can see you break that down into individual tasks that someone can then actually take away and deliver that in a number of hours. So that's how you generally structure your backlog. Next thing is source control. And source control is so critical for teams. Any team that is working that is more than one developer needs to really make sure they've got a good source control approach. And the reason for that is it protects code from accidental deletion or loss. When a developer moves on or moves off the project, for example, it keeps everything nicely protected. Gives good code governance. You can instigate approval gates to make sure that the right code control is going on. It allows for code branching so that multiple developers can be working on similar but slightly different nuances of the code base without interacting and interfering with each other. And lastly, a good source control tool will integrate with your IDE. So I commonly use Visual Studio Code, and a lot of source control tools integrate nicely with that. So I've got my source control immediately in my workspace, and also CI/CD, so that continuous integration and deployment to make sure that you can easily kind of ship code when it's ready to be shipped. Popular providers of this are things like Git, Team Foundation services from sort of Visual Studio's perspective, and another one called Mercurial as well. So there's a number of different approaches out there. And lastly on the list is CI/CD tools. So these will help you kind of automate a lot of the sort of monotonous tasks about getting code out the door to the right location. A number of things here. So for example, doing regular solution builds to make sure all the different aspects of your project or solution all fit together nice and tidily and can actually work in a logical way. They can automatically release code into an environment. So you can either say on a schedule to send code out to UAT or on a given commit to a branch, send code on its way. You can have those approval gates so that so the code only goes out when everyone is ready and agreed for it to go out. You can actually sort of check, what have I got actually deployed out in the wild versus what I'm meant to have deployed. And if there's any variances or difference, I can help me sort of resolve those differences. Commonly things that we see here are things like GitHub. Azure DevOps is one that I'm certainly very familiar with and works very well. There's also one called TeamCity, and there are numerous others out there as well that you may come across. But those are sort of a few of the different CI/CD tools that we see. Okay, so in summary, first things first, use an agile project style because it'll give you the maximum flexibility and allow you to really kind of tackle the problems as and when they arrive rather than trying to get stuck with all the planning. Acknowledge that there are nuances to a data science project that are not typical in other data project management. Making sure you've covered those off and you're aware of those is really important to gain success. Follow a clear process. Doesn't have to be the process I've listed here, but definitely follow a process so that everyone knows, what steps they're doing and when. And make sure you keep on top of that management and that monitoring so that you know where you are in terms of the project, you know where people are going to be, and you can kind of keep track of all the different assets that you're managing in the project. So look, thank you very much for attending the session today. I believe there's a few questions in the Q&A, so I'm happy to hang around and answer as many of those as we can get through in the next few minutes.
Great. Thank you so much, Matt. That's a lot of content in this hour session. So I know we're cutting close on times and we have quite a few questions in the Q&A. Are you able to just stay a few minutes more so that we can go over some of those?
Absolutely,
sure.
Yeah, of course.
Great. Okay. Let me just have a look at the Q&A box. So I have this question from Matthew. His question is, how can we choose which data science BI tools to use for a new industry we're not used to working in. Say we're going into DME, durable medical equipment industry, and have no idea where to start with building our first data science project in a new industry?
Yeah, okay, fantastic question there, Matthew. I mean, I think generally speaking, a good sort of robust list of requirements is going to really help you there. So putting technology to one side for a second, think about what does a generic technology solution need to achieve? And then you can then work through a tool comparison, right? You can start to line up various things that do meet those requirements and start to almost score those different tools against how they meet those different requirements. And that should give you a fairly good overall analysis as to which is the best tool to choose and what it may be lacking in some descriptions, but may make up for in spades in another kind of aspect of the project. Thank you.
Great. Next question from Nigel. Can you say a bit more about how to judge whether the data can support predictions?
Yeah, this is an interesting one. I mean, there's a lot that can be said about that, and you could almost do an hour topic in itself about, you know, how do you validate that a data set can support predictions? And I think, you know, that generally speaking, when you start up a project, there needs to be an agreement about what do we deem as success? You know, what quality of predictions we deem as good enough? And different use cases will have different metrics for success. For example, if we're trying to predict, you know, certain types of illness, we want that model to be very, very accurate, and it's going to be a very, very high bar. If we're trying to predict something like emissions over a certain period of time, we might find actually a fairly 80%, for example, success rate might be okay for that. It's enough. So making sure you're clear on what success looks like from a predictive capacity is really going to help you understand that. And then, as I say, using those things like correlation matrices, going deep in your EDA is really going to help you work out whether that data is going to support your predictions or not.
Thank you, Matt. Yeah, I feel like in my personal experience as well, a lot of people, like a lot of times people don't know kind of like the end results. So they expect those results to be perfect, but in reality, it's not always the case. So yeah, very important point. Thank you.
Yeah, and managing those expectations as you go through is really important. As you say, business users don't always understand that a prediction isn't always perfect every single time. So making sure that's really clear is dead important. Yeah, thank you, Maggie.
Absolutely. Okay, how can one let me just make it live. Always forget to do that. Next question from Mohammed. How can one handle dependency between project backlogs?
Okay, yeah, this is a really good one, actually. And again, it depends on sort of the different management styles and how they're being run. One thing that I've seen work really successfully is that as the team have their Scrum calls daily and they're catching up daily about progress, you nominate a day where you have a Scrum of Scrums, where essentially you pull all the project teams together in one sort of giant Scrum, if you like, and flesh out any issues that are sort of raised up to a project level. So that gives you a really good opportunity to, you know, surface any of those backlog issues and that kind of thing that you've got. Also, using a good backlog tool is really important, because then you can start to, you know, tie and link things together. So you can start to see where those dependencies exist. So, you know, very commonly I use Azure DevOps. There's also a tool such as Jira. You know, there's a number of tools out there that can handle backlogs and can help you, you know, resolve those dependencies where needed.
Okay, let's move on to the next question from Tariq. How does agile help with budgets? Budgets tends to be fixed and not iteratively updated.
Yeah.
Is the benefit only around flexibility on what the budget is spent on in response to learning by doing?
Yeah, so as you say, Tariq, yeah, absolutely. Budgets are generally fixed at the start of a project. And particularly, you know, I work in a consultative way. So, you know, we are coming into a business, and generally speaking, you know, you're given a budget and you have to deliver against that. So the thing is to use those project management tools to really be tracking that budget and using then your backlog as a tool to help you forecast. So you can start to then see, okay, I've got 10 sprints worth of delivery to get through, versus I've got 9 sprints left worth of budget with the team in this particular capacity. So immediately then, if you're doing your planning ahead of time enough, you know, yours then sort of 8 weeks or 8 sprints ahead of time saying to the customer or the client, we're going to run out of budget a sprint early, therefore we need to potentially, you know, ask for more budget or whatever. So the key thing is using those tools that you've got at your disposal, such as the backlog, to help you plan and forecast and make sure that you've got the visibility around that with enough foresight to do something about it before it becomes an issue.
Okay, next question from Mohammed. In the 7 steps on the slides, wouldn't it be necessary to clean the data in case there are some data anomalies in the data set?
Yeah, absolutely. No, it's a really valid point, and one I probably left out kind of mostly out of brevity. But yeah, no, you're completely right. You need to clean the data. In some cases, you find that data is coming from a relatively clean source already, and therefore, you may need less cleaning. But in some cases, a pre-clean data set can actually destroy some of the statistical value that you might want to extract from that data. So yeah, there may be specific data science cleaning that you might want to do. And I think the time to do that really is to understand and assess what cleaning is needed throughout EDA. And then feature engineering is a really good time to sort of start folding in that cleaning and then, turning that clean data into your features. Should we do one more, Maggie? Is that okay?
Yeah, let's do one last question, just because we're running over time. Sure. Okay. This question is from Francisca. Are there any available software tools that has the capability to do most of the 7-step process under one roof?
Okay, yeah, good question. I'm sure there's a number of tools that can do most of, if not some of those processes, particularly, when you get into sort of the data collection, data analysis, feature engineering, and the model selection process. There's a number of tools that can help you out there. I often favor Databricks, which operates on pretty much all of the main cloud providers. There's also things like Amazon SageMaker, there's Azure Machine Learning Services. I know there's a GCP one, but I can't remember the name of it now. But they're kind of these good packages that help you create models and push them out the door. Things that you might find are a bit more tricky to have in a software or a tool are things like the solution envisaging, and the review process, and monitoring is a bit more specialist as well. So you may get a tool that has all that built in and the monitoring on top as well. But monitoring might have to be a little bit more kind of rolled by hand, if you like.
Great. All right, I think that's the last question. Thank you so much, Matt, for this presentation and all the content that you shared with us today. And a lot of people have left a thank you in the chat. I think a lot of people have enjoyed your session and learned a lot from this discussion that we're having. And thank you very much, everyone, for joining us and asking all the questions. If you want to connect or if you have any more questions, feel free to reach out to either Matt or myself. Yeah. And thank you, everyone. Have a good one.
Thanks very much, everyone.